So the first thing we're going to look at is factoring when b and c are both positive. So remember, b and c, or a, b, and c, are really what we're looking at in the standard form of a quadratic function, right? Which is just going to be ax squared plus bx plus c. Remember, the a is just whatever number is being multiplied by x squared, the b is just whatever number is being multiplied by x, and the c is the constant, right? So in this case, we're expected to factor x squared plus 3x plus 2. So remember, we want to write this as the product of two binomials of degree 1, okay? And so here's kind of what we're going to do. Let's identify a, b, and c first, right? So our a term here, always today, is just going to be 1. So it's 1x squared, okay? So I'm just going to write a equals 1. Our b term in this case is the coefficient to x, which is a positive 3, so b equals 3. And our c term is just a positive 2, so our c equals 2, okay? Now remember, with this little chart we make, okay, where these two numbers that we get, they have to multiply to a times c, and they have to add to b, right? Okay, so a times c in this case, 1 times 2, these two numbers have to multiply to 2, okay? And they have to add to our b term here, which is 3, right? So again, in our heads we're thinking, all right, what two numbers multiply to 2 but add to 3? Okay, so what we can do here is write out all the factors of 2, and 2 is a prime number, right? So 1 times 2 is the only case that we have, right? So our numbers have to be 1 and 2, okay? And so the way that we write this out now, since we got 1 and 2 for our numbers, is we're just going to write this out as x plus 1 and x plus 2, right? And this is actually going to be our final answer, okay? Now, we can always check by foiling, right? So in our check here, all we're going to do is FOIL this. So first times first, I'll get x squared, right? Outside times outside, I'll get positive 2x. Inside times inside, I'll get a positive 1x. And then last times last, I'll get a positive 2, right? And when I combine like terms, I get x squared plus 3x plus 2, right? So I'm good to go. Let's go ahead and check out another example here, okay? So we'll check out the next one. I have x squared plus 8x plus 15. Okay, and for the first few videos here, I'm just going to write out standard form of a quadratic expression, right? So ax squared plus bx plus c, right? And we want to go through and identify what are a, b, and c. Again, notice I'm including the signs of a, b, and c. Okay, so again, this is 1x squared plus 8x plus 15. So I would say my a equals 1, my b equals 8, and my c equals a positive 15. Okay, now remember, these numbers have to multiply to a times c, and they have to add to b, right? So a times c in this particular case, 1 times 15 is 15, and my b term here is 8, right? So we have to think of two numbers that multiply to 15 and add to 8. So what we can do if we're struggling here is write out all the factors of 15. So 1 times 15 and 3 times 5, right? Do either of these, if we add them up, are they going to add to 8? And it looks like these ones will. Okay, so I'm going to write 3 and 5 are my magic numbers here. Okay, so those are the numbers that are going to go in my binomial factors, we call them. Okay, and so we're going to write this, we're going to factor this quadratic by writing it as the sum of two binomials of degree 1. Right, so this is x plus 3, that's that one of those numbers that we got, and x plus 5, okay? And this is our final answer, okay? Now remember, we can always check this with FOIL, right? So I'm just going to check with FOIL. I'm going to make sure that, you know, is x times x is x squared, x times 5 is going to be a positive 5x for outside. For inside, 3 times x gives me a positive 3x, and then last times last here will give me a positive 15. When I combine like terms, I get x squared plus 8x plus 15. Okay, and that was our original problem, so we know that we're good to go. Okay, so again, factoring is going to take a lot of practice, and we'll throw in some curveballs here in the next few examples.